regression on the SAT. It's actually one of the simplest parts of the test. Okay, maybe not the simplest, but it's actually so much simpler than people think it is. Like, you can literally learn it in this video alone and be almost a pro at it by the time you're done watching this. It's that simple. And I found a method of teaching Desmos regression that I think is the simplest and best on the internet. A lot of these videos are going to explain it to you in ways that are just so confusing, so weird, so, bringing in all these different things. But I'm just going to give it to you straight, simply, in a way that anybody can understand. If you want to know why you should trust me, I currently own the biggest online SAT Skool community. I've helped hundreds of students improve their scores. So Desmos regression, put simply, is a technique you can use. That's really all it is. It's a technique. It's not anything weird, not anything fancy or magical. And it's used to take information and find an unknown factor based off that information. I have this kind of stuff written here because information can mean equations, it can mean variables, it can mean points on a graph, and then unknown things can be the same stuff, but just different in an equation. Like, you can't be solving for something you already know, obviously. So you might get given something like these two equations, and then you have to figure out what are x, y, and z equal to. Or maybe you're given these 2 points, and you have to figure out which line would go through those points. Or you might get given one equation and have to figure out variables from that one equation. And you may be thinking to yourself, aren't there ways to do this without using regression? Yes, there are. For example, you could use the slope formula to find the stuff for this. Or for this one, you could just solve it like algebraically and figure out something that works. Or for this one, you could just like pick some numbers and see what actually matches up. Desmos regression is a simpler and easier way to do it. That's also a lot faster too. So I'd recommend using it, but one thing you should know is that you technically do not need to use Desmos regression. I've even talked to students who are like 1400 or 1500 level on the SAT who actually did not know anything about regression. So it's the kind of thing you don't technically need to know it, but it saves so much time, it's so good, it's so fast, it's so effective that you should learn it. Like, you're really kind of playing the game on hard mode if you're not spending the time to learn this technique. So there are 2 different types of Desmos problems. First are ones with a table. A problem like this is basically going to give you a set of points. So let's say x and y, let's say the points are 1, 2, then 3 and 4, and then 5 and 6. Okay, so pretty simple stuff here. And then after being given these points, I'm going to have to find out what would be the function that goes through them. So in a graph, which line essentially would go through all of these points? 1, 2, 3, 4, and 5, 6. That is literally it for how to use Desmos regression with a table. That's literally it in terms of when to use it. Whenever you're given points in a problem or anything resembling points, I'll show you some examples where it might be a little bit weirder than you initially expect. Just immediately go regression with a table. I've had students so many times before who have seen problems like this and they're like, I don't know what to do. And I'm like, it's literally points. Like, that's literally the only thing you can do, essentially, is use regression with a table. So as for how to actually use it, the first thing you do is you just type the word table into Desmos, and it gives you a table, of course. And then you put in the points that are given to you. So 1, 2, 3, 4, 5, 6. Then you have 2 different options for how you can actually find the function. Either you can just click here and then you get a drop-down menu. You can choose whichever one you want. It could be linear like this, it could be quadratic, it could be something cubic, anything that you want. Or if you want to be a little bit extra, you want to be a little bit zesty, you can actually go ahead and write out the equation. But sometimes you do need to actually do this. I'm going to show a problem in a second that does require you to write it out, so it's good to know this method as well. So if I'm trying to make a linear line, I can just type y equals mx plus b. The only thing though is I have to replace the equal sign with a tilde, and then I have to put 1s after all the y's and x's. You have to always do those 2 things. Like, if you don't do those, you're screwed. You're going to get an error every single time, and then you're going to be confused and cry to me in the comments probably. So make sure to do those 2 things. But if you do that, you get the same exact thing. You get a line that goes through the points, and it works, and it shows you what m has to be, what b has to be, all that stuff here. Those are the only 2 ways to do it, and that's really it for Desmos regression with a table. Let's solve a few problems. So for this one here, we have an exponential function that's going through this equation. It says b is greater than 1, b is not equal to 1. I'll show you in a second how to actually put that stuff in if it matters, but it probably won't even matter. Then they give you these points. So that's what really matters. Here's the points, and this thing has to go through these points. So let me start by making a table. 0, 5, 1, 17, and then 3, 377. And we have to use this equation. Now, theoretically, if you know your equations, you would know that this is just an exponential equation, but I'm just going to pretend like you don't know that. I'm going to actually go ahead and write it out by hand. So f of x, that's just another way of writing y. Unfortunately, you can't just literally put f of x in Desmos. For a problem like this, you cannot just put f of x in, so you have to replace that with y, and specifically y1. So y1, and then tilde instead of equal, a times b into the x1 power plus C. Okay, so there we have it. And as you can see, it goes through all of the points. One thing you should know, if it ever doesn't go through the points, like I guess if we put here like 5 and then 800, now you can see here it just kind of misses each of the points by like a small amount. If that ever happens, then you know something went wrong, because it should always be going through the points exactly without any kind of fluctuation, any kind of deviation, anything. So you probably did something, maybe you wrote a number in wrong, like I did here. I put 800, which is definitely not in this set of points. But regardless, something went wrong that you need to fix. Anyways, back to the problem that we were actually at hand. We have here this, and it does go through all the points. And so it asks us, what is the value of C? C would be 2 here. We don't need to worry about B being greater than 0 or B being not equal to 1 because it already matches those characteristics. But if we needed to put that in, we could do that by making a constraint like this. We could say here, B must be greater than 0. And then we could say, you know, B must be greater than 1. We can't say not equal to, but we can say greater than, so that it works. So you do that by putting squiggly brackets after the equation. But that doesn't matter for most of these. Typically, we're not going to have to do that. Now, this one's slightly weirder, so pay attention closely. We have a quadratic that has these 2 points, and the vertex is -2,5. So I'm going to go right here, table, put in the points, -2, and then 5, and then 4, and then 0. And then we have a quadratic. So I can do quadratic and like that. So you may be thinking, okay, this looks great, goes through the points, everything's fine. But there's one key problem here. It says here that the vertex is -2,5. You can see here the vertex of this is 2, -1.67. So that is not what the problem actually says. So we have to find a way to basically force the vertex to be this -2,5 point instead. It goes through the points right, but it just doesn't match what the problem is telling us. So to do that, I have to write a manual function, and specifically I have to write it in vertex form. This works because a vertex form is a function type where you can actually choose where the vertex is, obviously, since it's called vertex form. So that would be y equals a times x1 minus h squared plus k, and then hk is going to be where the vertex is, so I could put here minus -2 and then plus 5, and now it works. Now we have -2,5 as being the vertex, and we can see here, and the other x-intercept would be at, let's see, -8, 0, so -8. I'm just showing this to give you an example of a problem that will involve some other kind of higher level reasoning. You will not see these problems very often. So I was editing this video and I honestly noticed there is this one type of problem involving tables and regression that I kind of left out. So what if you have something like this? The linear function satisfies this, f of this equals that, and f of this equals that, where p is a constant. Which one gives the slope of f in terms of p? So you may be thinking to yourself, how does this involve points at all? How are there anything here that's like 1, 2, 3, 4? Well, the thing is, when it says f of something, like f of x is equal to some number, that in itself is a point, in case you did not realize. So if I say something like f of 3 is equal to 2, that's essentially the equivalent of putting here table and then 3 and 2. Just the exact same. There's literally no difference at all between those two statements. So for this one here, we can literally just say 3p minus 2, and then also 4p plus 5 for the first one. Then for the second one, we can do 5p plus 1, and then -2p plus 11. So this shows two things. First of all, it shows that f of something equals a number, just means a point you could put in a table. It also shows that you can actually put unknown values like p into the table itself. The one thing you have to do though is you have to actually define the thing. So I'm just going to choose a random value for p here. I'm just going to say p is equal to 1, let's just say. And now it works. Now it gives us values and everything is really good. So the rest we have to just do is pretty simple from this point on. It says that's a linear function, so I can just click here and do, linear. And I guess it kind of looks a little bit weird because it's just a horizontal line. So I'm just going to change this to being 2 instead. Again, it doesn't matter what value we choose for p. I'm just choosing a random value because regardless, it's going to be the same exact answer. And if you don't believe me, I'll show you why in a second. So if I make it 2 instead, okay, now we have a real slanted line here. It's saying which gives the slope of f in terms of p. So the slope here would be -0.857143. So I can just type in each of these to see which one gives me the right thing. So I know that D is going to be the right answer. But let me just try C first. So I can say P minus 1 divided by 2P plus 3. Okay, that's 0.14. That's not equal to this. And then let me try the last one. -6 P minus 1 divided by 2P plus 3. Okay, yeah, -0.857, that would be the exact same as this. And as you can see, if I change this value, if I make it 3 instead, yeah, it's still same value here as there. If I make it 4, again, same value here as there. So it doesn't change anything. It just different values, but still can show the exact same. So if you see a problem like this, don't get confused. You can still use regression with a table to solve it. What about regression without a table though? This is the thing that nobody really talks about. It's gotten a little bit more popular recently, but still a lot of people don't even teach this in their SAT courses, which is really unfortunate because some of these problems are low-key impossible to solve without using this method. But let me tell you when to use regression without a table. You use it when there are more unknowns, essentially, more variables you don't know and stuff like that, than there are equations. So an example of this would be like in this problem here. We have here, how many unknowns do we have? We have 1, 2, 3, and x was already there, and then 4. Okay, so we have 4 different unknown values here. How many equations do we have? We have 1, and I guess you could count this as 2. So yeah, we have 2 equations and 4 different variables. So 4, in case you don't know, in case you're not really good at math, 4 is greater than 2. So therefore, we're gonna have to use regression without a table. The way to do this is I just type in the exact equation and I do the exact same stuff from before. I place the x's and y's with x1 and y1, and I put a tilde instead of the equal sign. So we can say here mx1 minus 4, nx1 plus 3, and then tilde 10x1 squared plus kx1 minus 12. And so we would be pretty close to done, but remember those constraints that I mentioned before. Sometimes it'll give you other pieces of information for these problems that you have to also, it's kind of like slot in there just so it also works out. So it says here for all real values of x. Whenever it says that, you do this exact thing. Don't forget this because this is really important. Put x1 equals square bracket 1 dot 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 10. That's exactly what you do. The reason why you're doing that is because it says all real values of x. You're trying to make it so this function is considering more values of x than just one value. If you don't put this in, it's going to just pretend that x is equal to 1 and give you an answer based off of that. We want it to be all the different values that x could be. I know there are only 10 values x could be in this example, but if you have 10, typically that's enough sample variance to account for most values. So we have here a little bit of a better, more accurate thing, but we also forgot another thing. M plus n equals 7. So I'm going to show you another way you can do something like this in a second, but if you don't want to go through that process, I could also just make another line and type m plus n equals 7. Now, the one issue is we have to do some algebra on it because it's not going to register if I just put in this exactly because you have to define it in terms of a variable. So if I subtract n from both sides, we get m equals 7 minus n. And so now that works, and now it's giving us an answer. So it says k must be equal to 7, and the only one that has 7 included is b. Let's look at this one now. So we have 1, 2, 3 different variables and only 2 equations, so we have to use it without a table again. When you have 2 equations like this, like you have equation 1 and equation 2, you have to actually do this kind of weird thing where you make a bracket system. So this is going to be really confusing the first time you see it. I haven't seen a single student who hasn't gone at least a little bit confused when they saw this the first time, but don't worry, you'll make it through and it's actually a lot simpler than you may realize. So basically you make a square bracket and then you put the left side of the first equation in there. So left side of this would just be u squared plus v squared. Okay, so that works. And then you put the left side of the second equation. So I would just put in here uv. Okay, then you close the thing. So you have the left sides of both of the equations. Then put a tilde again, and then do the right sides of both of them. So 4k, con 4k, I guess. And then we have k minus 7. So k minus 7 like that. And then we put another square bracket, and that is it. So hopefully you didn't get too confused there, but the only part that's kind of weird is that we're matching up the equations, basically. We have the left side, and then the right side, and the left side, and the right side. I know that's not what you would think to do. I know you would think to just put them both in the same thing, but that's not how regression works, unfortunately. Deal with it. So for this problem, it asks us, what is u plus v squared in terms of k? So let's see what we need to still do to solve this. For the constraints, they give us k must be greater than 0. Thankfully, k is already greater than 0 here, but if I want to just really make sure, if I'm really not sure about if this value is greater than 0, I guess, I could put in here another squiggly bracket and say k must be greater than 0. This is just like I did for that other problem before. So yes, same value because it was already fine. And then we have u plus v squared. To do that, I can just see what would that be equal to. So u plus v squared. So that'd be this whole long ass thing. And then I can put there, in terms of k, I can just try out each of these different answers. So 2k minus 7, okay, that's not the same thing. 3k minus 14, no, it's not the same either. 4k minus 7, and then 6k minus 14. Okay, yeah, that gives us the same exact thing for both of those. So Therefore, D is going to be right here. As for the real values, when it says real numbers, that doesn't really mean anything. You don't need to worry about any constraints for that, by the way. So in this one here, they give us h of x is equal to this whole thing. And they say that h0 plus h6 equals 34, h1 plus h5 equals 22. So to do that, the first thing I do is I just write in the equation they give us in the regular form. So no kinds of tildes needed here. We can just write it in. So h of x is equal to ax squared plus bx plus c. And then the next thing I do is I just do the exact same thing as for the other problem, except now I just put in these numbers, these values instead. So I do the left side, the first one should be h of 0 plus h of 6. Then the left side, the second would be h of 1 plus h of 5, square brackets, and then tilde, 34, and then finally 22. So yeah, it's actually literally that simple. We have that here. Let me see, are there any other constraints we have? So it just says constants here. That doesn't mean anything. And yeah, okay. So then all I have to do left is just find out what this thing would be. So h of 3 would just be h of 3 like that. And we have 6.2, which is the answer here. So the only thing that's different about this one is that you just have to put in the function first of all, and then do the actual work. But besides that, everything else is the exact same. Now, the last thing I want to show here is sometimes you can have more than just two equations. So you just do this the exact same way, still in the brackets, still match it up, but just more than two equations. So let me just write out what each of them would be. They say the volume of container A is 250% of container B. So I could say here A essentially equals 250% of B. Then second one here, A is also 0.04% of C. So I can say 0.04% of C. And then it says volume of C is P% of container B. So I can say P% of B. And then finally asks what is P over 100. So I can just put this into the brackets like before. So A, and then C would just be the left sides. And then we have the actual work on the right side. So I can just put in 250% of B. That's a really useful life hack. You can just put percentage of something into Desmos. You don't need to actually calculate it out. Then 0.04% of C. And then finally P% of B. We get given here that all these different things, and I can just do here what is P divided by 100, and that gives me 6250. That would be the answer for this one. In my community, in the link in the description, I have some more practice problems that deal with both of these, both with a table and then also without a table. So definitely check that out if you want some more practice. Plus, feel free to join my community if you want a very fun and exciting way to study for the SAT. Plus, probably also get a really good score really fast. Definitely can help you out before your next test. Anyways, I hope you do really well on the SAT. Hope this video helps you learn regression. I'm out. Stay Gucci.